This video is all about the gas laws. So how to relate properties of gases through mathematical equations and then how to actually do those calculations. So again, gas laws relate two or more properties of the gases. Think pressure, volume, temperature, or number of moles are the properties we're talking about. Okay, so what's the first one? Boyle's law. What happens to the pressure inside of a balloon if you squeeze it? So think about squeezing a balloon. What is going to happen to pressure? Pressure is going to go up, right? It increases. You could even get the pressure so high that you make it pop, right? That you exceed the pressure that the balloon can withstand. So pressure is going to increase and increase and increase as the volume decreases. That is what we call an inverse relationship. So inverse variables mean that as one variable goes up, the other variable goes down. And so we have a graph over here of pressure versus volume, and we see that that pressure skyrockets as the volume gets smaller and smaller, the pressure of the gas goes up. So Boyle's law relates changes in the pressure and volume, and it does so by the following equation. P1 times V1, so this is multiplying one pressure times one volume, is going to equal P2 times V2. The second or new pressure times the new volume. Here we're saying N and T are going to be held constant. Constant T means constant temperature. You're not changing the temperature of the gas. Constant N means you're not constant amount of the gas. You're not letting any moles of gas in. You're not letting any moles of gas escape. So no gas is going in or out of the container. The units don't really matter as long as they're consistent, right? Like you just have to have both pressures in the same units. They could both be in millimeters of mercury. They could both be in torr. They could both be in ATM. Your volumes could both be milliliters or they might both be liters. So long as they're the same volume, the units don't matter. Okay. Next up is Charles' law. Charles' law says what happens to a balloon if you heat it up? We're going to talk about temperature. Well, if you heat up a balloon and you keep the pressure and the amount of gas constant, the volume will increase as the temperature increases. So this is a direct relationship. One thing goes up and then the other is going up. One variable is increasing and the other is increasing. So here's a graph of a direct relationship between temperature and volume. As you double temperature, the volume doubles. If the volume started off at 1 liter and 100 Kelvin, at 200 Kelvin, it's 2 liters. At 300 Kelvin, it's 3 liters. At 400 Kelvin, it's 4 liters. So Charles' law is going to relate changes in temperature and volume. And then you can write this V1 over T1 equals V2 over T2. So your initial volume divided by your initial temperature is equal to your final volume divided by your final temperature. I find that students make the most mistakes when they are looking for an unknown variable in the denominator in the bottom of one of these equations. So sometimes it helps to just flip the equation and use it in the opposite form. So you can also write it T1 over V1 equals T2 over V2. Now, N and P are going to be constant. That means this is held at constant pressure, and that means no moles of gas are going in or out of the system. Now, one variable super important here. Temperature has always got to be in Kelvin for any gas laws. Otherwise, you might divide by 0. Negative temperatures might mess things up. You could end up with a negative volume. That wouldn't make any sense. So we can't use a negative temperature and end up with a negative volume. We can't divide by 0. So we've got to use Kelvin to avoid all that mess. Charles' law really provided the first estimate of what absolute zero might be, what temperature that might occur at, because it allowed us to extrapolate all the way down to 0 volume. So where a sample was going to have 0 gas volume to figure out, well, what temperature might that occur at? What temperature might the sample have an estimated 0 volume? And that gave us our first estimate of absolute zero of negative 273.15 Celsius. So kind of cool that we can do that with Charles's law. Okay, up next is Gay-Lussac's law. This really is going to ask us the question of what happens to the pressure of a gas if you heat it up. So if you, heat and heat and heat the temperature of a gas, the pressure is going to increase and increase and increase. So pressure goes up as temperature goes up. Gas particles start moving faster and faster. They start hitting their container wall then more and more frequently, and that's our measure of pressure. So Gay-Lussac's law relates changes in pressure and temperature. And again, here's another direct relationship. Just like Charles's was direct, this one is direct as well. And this also says that we're got to assume that we have constant volume and a constant amount of gas. We're not letting any gas in or out, and we're making sure that the volume stays constant. And as the temperature goes up then in that fixed container, the pressure will go up. More temperature will result in particles moving faster, making more collisions against the container, and that will increase pressure. So this law looks like P1 over T1 equals P2 over T2. You can flip this. Say you're stuck solving for like a T1 or a T2 that's in that denominator. We'll flip it. T1 over P1 equals T2 over P2. That will work too. So you can flip these to make the algebra easier for you if that's what you want to do. It works for some people. I think it's a fairly good strategy, but you don't have to employ that strategy. Okay, again, temperature's got to be in Kelvin. For all of our gas laws, we always have to be in Kelvin. Okay, and then next, we've got one more direct relationship to cover. What happens to a balloon when you blow into it? So you put more and more gas into it. If nothing else is changing, the volume is going to have to get bigger when you put more gas in it. That's the only way to keep pressure and temperature constant. So Avogadro's law is going to relate the amount of gas, N, and the volume. And remember that amount could be N or moles, right? And this is when you're keeping pressure and temperature constant. So this is another direct relationship. So really all the relationships were direct except Boyle's law, except pressure, volume, or Boyle's. That's the only indirect relationship here in the gas laws. So this one's N1 over V1 equals N2 over V2. Here's the idea. Molar volume is a really interesting concept. The idea is this, like you could have 1 mole of N2 of nitrogen gas, and you react that with 3 moles or 3 molecules of hydrogen gas. And what you'll get are 2 moles or 2 molecules of ammonia gas. So let's think about what Avogadro's law says then is 3 moles of hydrogen gas are going to have 3 times the volume that this 1 mole of nitrogen gas has. The 2 moles of ammonia gas that are formed, well, those are going to have twice the volume that the 1 mole of nitrogen gas had. So it's this idea also of a molar volume comes from Avogadro's law. The idea that the amount of gas or moles of gas is directly proportional to volume. And what we also learned through this is that 1 mole of any gas has a molar volume of 22.4 liters. So if you have 1 mole of nitrogen gas, 22.4 liters. 3 moles of hydrogen gas, well, you have 3 times 22.4. You have 66 and some liters, right? So you just know that the volume of a mole of any gas at standard temperature and pressure is fixed. And we'll talk about standard temperature and pressure, or STP, in just a little bit too. Okay, so if we look at these pictures on the right of some different gases, let's think about, well, what do they have in common? They look like they're all taking up the same volume. And let's check out the particles. They have 1, 2, 3, 4, 5, 6, 7, 8, 9. If we count these as particles, count a whole molecule as a particle, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you guessed it, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 particles in each balloon. So they each have the same volume and they each have the same number of, 9 particles in each one. So what's different about them? What sort of gives? Well, it looks like they're different molecules, like the particles are not the same. And since they are different particles, they're going to have different masses inside of those. So it's really interesting that a mole always has this fixed volume at STP, even though it can have different particles and different masses. So hopefully you have a little bit more knowledge about the general gas laws that now you can try to apply those. Keep in mind, Boyle's law is the only inverse law. Pressure or volume is the only inverse relationship. Each of the other relationships that we looked at were all direct relationships, and when one thing went up, the other went up. Only when pressure goes up is volume going down for Boyle's law.